Hi students, this is our 10th lecture of units and measurement, and we were discussing about the combination of errors. In the last class, we had already discussed the combination of errors during addition and subtraction, and today we are going to the multiplication of quantities with respect to the errors. What happens to the errors when two quantities are multiplied together? And before starting, just introducing, this is our channel Physics Gallery, Asha Pino. And any doubts related to the topic discussed, you may ask it in your comment box. Okay. So, we are going to multiply two quantities with respect to the errors. That is, suppose a quantity is given. Two quantities A and B are given as. Two quantities A and B are given as A plus or minus delta A and B plus or minus delta B. Okay. Two quantities are given as A plus or minus delta A and B plus or minus delta B. What does it mean? That is, our first quantity is A, but when A is measured, some error occurs. That error is delta A. Okay. Similarly, our second quantity is B, but when B is measured, some error occurs, and that error is delta B. Okay. And we have to multiply this A and B. We have to multiply A and B to obtain the product Z. We are going to find the product Z with respect to the errors. Okay. So we are going to take, we know Z is equal to A into B. But since A has certain error, B has certain error, the product will also contain certain error. Surely the taken quantities have error, so the product will also have some error. So we will write Z plus or minus delta Z. That is the product in terms of the error. We are taking the product in terms of the error. Is equal to A plus or minus delta A. This is A into B plus or minus delta B. Is it clear? Okay, is it clear? Now, Z plus or minus delta Z equal to, expand, open the bracket, A into B, AB plus or minus A into delta B, A delta B plus or minus delta A into B, B delta A plus or minus delta A into delta B, delta A, delta B. Is it clear? Once more, Z plus or minus delta Z equal to, what is AB? AB is Z itself. Z plus or minus A delta B plus or minus B delta A. And now the last term in the equation is delta A into delta B. Here we have to think. Delta A is the error in the measurement of A. Okay, we have measured A, but a small error occurs there. That is delta A. Similarly, delta B is the error in the measurement of B. When we measured B, a small error occurs there. That is delta A and delta B, both of them are very small values. Both of them are very small values. And these small values are multiplied together. What happens when two small values are multiplied together? For example, delta A is given as 0.01. Delta B is given as 0.02. We have to take delta A into delta B. What will be the answer? 0.01 into 0.02. The answer becomes 0.0002. Is it clear? The errors were 0.01 and 0.02. But when they are multiplied, a very small value is obtained. This small value will have to be added or subtracted with this value. Okay. Okay. Suppose this value is at plus or minus A delta B plus or minus B delta A. This value has a number. Suppose the value, when adding all of this, we got 5. Suppose its value is 5. To this 5, we are going to add delta A, delta B. Add or subtract, plus or minus. Suppose we take plus this. The value is 0.0002. What is the effect? 5.0002. Is it clear? Suppose we will subtract this small value. What will be the effect? 4.9998. Okay. For us, this value is taken as 5 itself. This is also 4.99998 is 5 itself. That is there any change in the value? Is there any change in the value when a very small quantity is added to it or subtracted from it? No. Do you understood what we have said? We have said that when a very small value is added or subtracted from a quantity, no change is coming. Is it clear? There is no any change in the value. Okay, 5.0002 is also taken as 5. 4.9998 is also taken as 5. So is there any change in the value? Then why we had to add this very small value to this term? Is it clear? That is, we are going to neglect the value delta A into delta B is negligibly small. So we don't have to add it into the equation. Is it clear? Is it clear? Pause the video once more. Here what I have told you. So here we will write delta A into delta B is negligibly small. It is negligibly small. Okay, delta A into delta B is negligibly small. So it is removed. Is it clear? Do you understand what we have told? Okay, is it clear? Next, Z. Then we will write plus or minus of delta Z is equal to plus or minus of A delta B plus or minus B delta A. Minus cancelling. Delta Z is equal to A delta B plus B delta A. Is it clear? Okay, now dividing the equation with Z. We will get delta Z by Z is equal to A into delta B by Z plus B into delta A by Z. Or we can write delta Z by Z is equal to A delta B by, what is the value of Z? AB plus B delta A by, what is the value of Z? AB. Now cancelling, where we will write AA, BB. We will write delta Z by Z is equal to delta B by B plus delta A by A. Do you understood? Pause the video and write this. Understood this, what we have written. Okay. Okay, time is over. 1, 2, 3, 4. You have completed. Now we are going to discuss this. What is this equation? What is this? When we multiply two quantities A and B to form the product Z, we had got an equation like this. Delta Z by Z is equal to delta B by B plus delta A by A. It means that this is the fractional error of Z. That is, Z is the product. This is the error. Error by number is called as error by the true value, or the number is called as the fractional or relative error. So this is the relative error of the product Z. This is the relative error of the quantity B. And this is the relative error of the quantity A. What is the relative error? Error by value, true value or taken value. Okay, so we can say when two quantities are multiplied, the relative error the relative error in the product, the relative error in the product will be the sum of the relative errors, will be the sum of the relative errors of the quantities multiplied. That is, when two physical quantities are multiplied together to obtain a product, the product will attain certain error. The relative error of the product will be equal to the relative error of the product. Error in the product will be the sum of the relative errors of the quantities multiplied together. Is it clear? In addition and subtraction, we have directly added the errors. We have directly added the errors when two quantities are added or subtracted. But in multiplication, we will never directly add or multiply the errors. You have to take the relative error of the product as the sum of the relative errors of the quantities multiplied. Is it clear? Pause the video, take the notes. Hoping you understood. That is, two physical quantities A and B are given as A plus or minus delta A and B plus or minus delta B. We have to take the product Z. Z is equal to AB. But since the taken quantities have certain error, surely the product will have also certain error. So, in terms of error, we will write Z. Z plus or minus delta Z is equal to A plus or minus delta A into B plus or minus delta B. Opening the bracket, in the last term, we had seen delta A, delta B, both of them are very small values, and on multiplying two very small values, the product is negligibly small. So we have neglected this from the equation and then written as this. AB equal to Z. Z cancelling, plus or minus, plus or minus, plus or minus removing, delta Z is equal to A delta B plus B delta A, dividing the equation with Z. Here delta Z by Z is equal to, here the Z may be taken as AB, BB cancelling, AA cancelling. Finally, we got the equation delta Z by Z is equal to delta B by B plus delta A by A. That is, when two quantities are multiplied together, the sum of the relative errors of the quantities will be equal to the relative error of the product obtained. Is it clear? Hoping you understood what we have studied now. Okay, pause the video. Once more, take the notes. Once more, try to understand what we have studied. Hoping all of you understood the topic. Okay, if so, we are going to a numerical. We are going to take a numerical problem. That is, in a given question, it is given that the length and breadth of a rectangle, the length and breadth of a rectangle are. In a given question, they have provided that the length and breadth of a rectangle, we will write. The length and breadth of a rectangle are given as L is equal to 200 plus or minus 5 meter and breadth B is equal to 50 plus or minus 2 meter respectively. Okay, the length and breadth of a rectangle are given as L is equal to 200 plus or minus 5 meter and breadth B is equal to 50 plus or minus 2 meter respectively. Question is, find the area of the rectangle. Find the area of the rectangle with its percentage error. With its percentage error. This is the question. Find the area of the rectangle with its percentage error. Okay. Okay, that is, if length and breadth are given, you know how to take the area of the rectangle. Very simple. Okay, you have studied in your smaller classes. That is, area is equal to length into breadth. We know that. Okay, is it clear? But here length and breadth are given with their error. So when we multiply, the area will also contain some error. But whether we directly add the errors, here the error is 5, here the error is 2. So whether we directly add the errors to obtain the area, the error in the area, no. The first step is to take the relative error or percentage error of A. So how to take the percentage error of A? We will write the percentage error in A is equal to, how to take the percentage error? Relative error into 100. Okay, that is delta L by L into 100. That is equal to delta L. That is, when 200 is measured, 5 is the error. So delta L is 5 for 200. When 200 meter is measured, 5 is mistake into 100. Cancelling 100 to 2.5 percentage. Okay, so what is the percentage error in A? Percentage error in A is 2.5 percentage. Relative error into 100 is called as percentage error. Similarly, the percentage error in A, sorry, we have taken the length. Okay. Percentage error in length here. Similarly, sorry for the mistake. Okay, here we have taken the breadth. That is relative error into 100. Relative error into 100. Delta B by B into 100. That means when the breadth is measured as 50, there is an error of 2. So for 50, 2 is error. We can write for 50, 2 is the error into 100, 2, which is equal to 4 percentage. Okay, so the percentage error of length is 2.5 and the percentage error of breadth is 4 percentage. Now area is equal to length into breadth, which is equal to length value 200 into breadth is 50. Okay, with its error, the errors have to be added together. The percentage or the relative errors have to be added together. Okay, we will write it as 2 5s are 10, then 3 zeros plus or minus. This is 6.5 percentage. So what is the area of the rectangular field with respect to the percentage error? Relative error into 100 is called as percentage error. Okay, so the value becomes 10,000 plus or minus 6.5 percentage meter square area. Is it clear? Do you understood how to take the errors when two quantities are multiplied together? We never add the errors together. In addition and subtraction, we may add 5 and 2 directly. But in multiplication, we never add the 5 and 2 directly. We have to take the relative and the percentage error. Then they have to be added. Is it clear? For multiplication, the relative error of the product will be equal to the sum of relative errors. Tell me, relative errors of the quantities multiplied together. We never directly add the errors given. We have to take the relative error, and if percentage error is asked, you have to take the percentage error. Okay, relative error into 100 is percentage error, and then take the value. So hoping you understood all of this topic. If there is any doubt, you may ask it in the comment box. Okay, we will discuss it in the next lecture. Hoping you will study it very well. Till the next video, bye.